properties of the convolution. Let's say y of t equal to x of t convolution with h of t. Now the first property, yt equal to integral of tau equal to minus infinity to plus infinity x tau h t minus tau d tau. Now I can write this equation as m tau equal to minus infinity to plus infinity x of t minus tau into h of tau d tau. I can prove this easily. This I know, so I will put just t minus tau equal to some m tau limits. So 0 minus d tau equal to dm. From this, if tau equal to minus infinity, then m equal to t minus of minus infinity, that equal to plus infinity plus t. You will get infinity. If tau equal to plus infinity, m equal to t minus infinity, that is minus infinity. So limits are also changed from this. Now yt equal to, if tau equal to minus infinity, m equal to plus infinity, right? M limits are plus infinity to minus infinity, and x of tau. From this, tau equal to t minus m. H of t minus tau. The t minus tau is m, and d tau is minus dm, right? Now the limits are plus infinity to minus infinity, right? Here I have minus, so you can write m equal to minus infinity to plus infinity x of t minus m h of m dm. If you change the limits from lower limit to upper limit to lower limit, you have to put a negative sign here. Here already I have negative sign. Now you can replace m with tau, because it is a dummy variable, right? The dummy variable. Replace m with tau, that equal to tau equal to minus infinity to plus infinity x of t minus tau h of tau d tau. Okay, so this is nothing but y of t only, right? Y of t is integral minus infinity plus infinity x of tau h of t minus tau d tau, right? Yeah. Now this is the first property, and the second one, right? This we already derived. So now I want to find out dyt by dt with respect to t is equal to integral tau equal to minus infinity plus infinity x of tau. The integration is with respect to tau, so we are differentiating with respect to t, so we can directly differentiate this h, because h is the only function which is a function of time here, the function of t, d by dt of h of t minus tau d tau, and this is equal to, here tau equal to minus infinity plus infinity h of tau. Here the function is x of t minus tau. Here x is the function of time t, so I can differentiate d by dt x t minus tau into d tau, right? So from this is some function, right? Let us say some f of t minus tau. This is some function. Let us say some g of t minus tau, right? So I will write this as x of t convolution with d by dt of h of t, d by dt of f of t. Here f of t is h of t, right? I can also write this equation. This is h of tau, that is h of t convolution with this function d by dt of x of t. Okay, this is dy of t by dt. This is the second property. And this property, let's say d square y of t by dt square. We are again differentiating. So let us say this is one function, this is one function, this is another function. This is one function, this is another function. So from this definition only, from this what I mean, so from this property only, we are differentiating one time here. Then you can differentiate either of the signal one time. So here also, here we have x of t and d by dt of h of t, right? That is dy by dt. We are differentiating this one. Let us say some other signal. This is some wt, dw by dt. So we have to differentiate one of the signal. So here I will differentiate dxt by dt. Here I will differentiate xt, and I don't do anything on d by dt of ht. Okay, or I don't do anything on xt. I'll differentiate the second signal, that is d by dt of ht. If differentiate this, we'll get d square ht by dt square. Or from this, I will differentiate ht, dht by dt. I don't do anything on d by dt of xt. Or I don't do anything on ht, and I differentiate xt. I differentiate d by dt of xt. So t square by dt square of. I have deduced this. I have deduced this from the above property. Yeah, from this property only. Third property. Let us say y of t equal to x of t convolution with h of t equal to integral minus infinity plus infinity x of tau h of t minus tau d tau that equal to integral minus infinity plus infinity. These are tau limits. X of t minus tau h of tau d tau. This is from the first property. Now I am applying some y of t minus t1. I am applying one y of t minus t1, that equal to, wherever t is there, replace that t by t minus t1. So tau equal to minus infinity plus infinity x of tau h of t minus t1 minus tau d tau, that equal to tau equal to minus infinity plus infinity x of t replaced by t minus t1 minus tau d tau h of tau d tau. So here this one, here this one. Okay, I can write this x of t. This is x of t convolution with h of t minus t1. From this I can write x of t minus t1 convolution with h of t. Okay, this is y of t minus t1. If y of t equal to x of t convolution with h of t, and y of t minus t1 equal to, you can delay in any one of the signal x of t minus t1 or h of t minus t1. You can't do this delay in both the signals. Okay, any one of the signal h of t minus t. From this formula, from this property, I can deduce one more equation, like now y of t minus t1 minus t2. Then, so first what I do, I know y of t minus t1, right? Then again I have to delay some t2 also. So what I do, first I will delay in x of t from this equation only, x of t minus t1, sorry, x of t minus t2 convolution with h of t minus t1, or I will delay t2 in the second signal. Okay, we have to delay. This equation tells y of t minus t1 equal to x of t convolution with h of t minus t1 and equal to x of t minus t1 convolution with h of t. This equation tells if you delay t1 amounts in y of t, you have to delay any one of the signal. You should not delay in both the signals. Okay, so from this property, I will deduce, let us say y of t minus t1 minus t2. I have already available y of t minus t1 here. This is this equation. So I have to delay t2 amount. So from the property, from this property, what I have to do? I will delay in any one of the signal. I won't delay in two signals at a time. Okay, I have to delay in any one of the signal. First, I will delay in the signal x of t. What is the amount? T2. X of t minus t1. That is the amount t2 delay. That is the amount of delay t2. So I will delay t minus t2 in first signal. I want to delay in the second signal. I will write like this. Or I will put x of t as it is and I will delay in the h, that is h of t minus t1 minus t2, or from this equation. First I will delay in the x, that is x t minus t1 minus t2 convolution with h of t, or I will delay in ht. I will put x as it is, x t minus t1 as it is. I will delay in the h minus t2. Okay. So I just deduced this equation from the above equation. I think there is no confusion here. So if you want to delay some t minus t1 minus t2 amount of delay, you have to delay both t1 t2 in one signal. You can delay both t1 t2 in one signal. Here you put another signal as it is, or you can delay t1 amount in one signal and t2 amount in another signal. Okay, here also you can delay both t1 t2 in one signal and put another signal as it is, or you can delay t1 delay in one signal and t2 delay in other signal. Yt equal to xt convolution with t equal to integral of tau equal to minus infinity to plus infinity x tau h t minus tau d tau. Now I want to calculate x of at convolution with h of at. This is my interest. Okay, what I have to do. So let us say this convolution is integral of tau equal to minus infinity plus infinity x of a tau h of a t minus tau d tau, right? Now integral of tau equal to minus infinity plus infinity x of a tau h of a t minus a tau d tau. Now this a tau, let us say this a tau equal to some m, right? Now a into d tau equal to dm and d tau equal to 1 by a dm, and limits tau equal to minus infinity, then a tau equal to minus infinity, then m equal to a into minus infinity. If a is greater than 0, I am taking a greater than 0, positive, then minus infinity to positive, minus infinity. If a less than 0, you will get negative. So minus of minus infinity will get plus infinity. So I am taking here a greater than 0. I will explain for a less than 0 also. Tau equal to plus infinity, that is upper limit, m equal to a into plus infinity. Here you will get plus infinity. If a less than 0, here I am assuming a greater than 0. If a is less than 0, this a becomes negative. Negative multiplied with plus infinity will get minus infinity. A is less than 0. Okay. Now, there is this equation. So m equal to, limits are changed. M equal to minus in, if tau equal to minus infinity, m equal to minus infinity. If tau equal to plus infinity, m equal to plus infinity. And x of a tau is m, and h of a t minus a tau is m, into d tau. What is d tau? D tau is dm by a, right? This one, dm by a. So now you can write 1 by a integral of m equal to minus infinity to plus infinity x of m h of a t minus m dm. Okay, this is convolution of x of a t and h of a t. Okay, but what we know, let's say y of t equal to x of t convolution with h of t. That is, we know that tau equal to minus infinity plus infinity x of tau h of t minus tau d tau. Okay, so in this equation m is a dummy variable, just m replaced by tau. Okay, just m replaced by tau. What you get? X of a t convolution with h of a t is equal to 1 by a integral of just m equal to tau equal to minus infinity plus infinity x of tau h of a t minus tau d tau. So from these two equations, okay, from these two equations, this is y of t, this is the argument t, y of t, right? This is the argument t, y of t. Here t is there, okay, here, but here a t is there. So what you have to put in this? Okay, 1 by a, if t is there, here yt, right? T is there, yt. If at is there, yat. That's it. Okay, so x of at convolution with h of at is 1 by a yat. But if what, this is for a greater than 0, right? What if a less than 0? I'll explain there. If a less than 0, what you get here? If a less than 0, here, suppose a equal to -2. Okay, if a equal to -2, x of at convolution with h of at equal to integral of tau equal to -infinity to +infinity x of a tau h of a tau minus h of a t minus tau d tau, right? Integral of tau equal to -infinity +infinity x of a tau h of a t minus a tau d tau. Now I will substitute a equal to -2 here, right? A equal to -2. So substitute this in a equal to -2. Tau equal to -infinity +infinity x of -2 tau h of -2t minus, in place of a, -2. So this become +2 tau d tau. Take this -2 tau equal to some m. -2 into d tau equal to dm. D tau equal to -1/2 into dm. And the tau limits tau equal to -infinity, then m equal to +infinity from this equation. If tau equal to +infinity, m equal to -infinity, m from this equation itself. Substitute tau equal to +infinity here. Tau equal to +infinity, infinity into -2, you will get -infinity. Now, so m equal to +infinity to -infinity. Okay, limits. If tau equal to -infinity, m equal +infinity. Tau equal +infinity, m equal to -infinity. Then x of -2 tau is m and h of -2t. So +2 tau is -m. D tau is -1/2 dm. This. Now here we have obtained minus here. Okay. So but the limits are m equal +infinity to -infinity. So I need m equal to -infinity to +infinity. So m equal to -infinity to +infinity x of m, you can put minus here, h of -2t minus m into -1/2 dm. This minus into minus plus, right? Now m equal to -infinity +infinity, here 1/2 x of m h of -2t minus m dm, right? But what is this? What is this? Here in place of, you can change m to tau, m equal to tau. Okay, here 1/2 tau equal to -infinity +infinity x of tau h of -2t minus tau d tau. So this can be written as, if t is there, you can put y of t, because we know the definition. From the definition, y of t equal to x of integral of tau equal to -infinity +infinity x of tau h of t minus tau d tau. So here t is there, so that is why we are putting here t. But here -2t is there, so this entire thing up to here is 1/2, so here is y of -2t, right? So but in denominator, even though a is negative, we are getting positive value of 2. Okay, so that is why whether a is positive or negative, so if y of t equal to x of t convolution with h of t, then x of at convolution with h of at equal to 1 by mod a into y of at. a equal to minus 2. Here in denominator you have to put plus 2 only, and in argument you can put minus 2, y of minus 2t. Okay, this is the one of the property. So the property, x of t convolution with del of t. So integral of minus infinity plus infinity x of tau del of t minus tau d tau, right? But this argument del of t exists, or del of t must exist only at t minus tau equal to 0, right? So only at t equal to tau, that is tau equal to t. Remaining all cases will get 0. Tau equal to minus infinity plus infinity x of t into del of t minus tau d tau. X of t is a constant with respect to tau. Del of t minus tau d tau. This value is 1. So this is x of t. So x of t convolution with del of t is x of t only. And you can easily derive x of t minus t naught convolution with del of t minus t1 equal to x of t minus t naught minus t1. You can easily derive from the above property itself. Okay. Important results. In fact, first one, u of t convolution with del of t. Anyway, any signal convolution with del of t is same that signal itself. So u of t only. Second, u of t convolution with u of t. This is r of t. It is t into u of t. I will derive this. Next, r of t convolution with u of t. This r of t is t ut convolution with ut. You will get t square by 2 ut. These three results are important. I will derive this. First one is from the property. First one. The second one I will derive. So second one, ut convolution with ut. So take tau equal to minus infinity plus infinity u tau. Second signal also ut. So ut minus tau d tau. But the tau limits. This is important. So this first signal is u tau, second signal is ut minus tau. U tau equal to 1 for tau greater than or equal to 0 and 0 for tau less than 0. Okay, this is first one. And second signal ut minus tau equal to 1 if t minus tau argument should be greater than or equal to 0. That is tau t minus tau should be greater than or equal to 0. Tau should be less than or equal to t. Right? That is 0 if tau is greater than t. So tau limits are, so from this tau limits, tau should be greater than or equal to 0, 1, otherwise 0. 0 multiplied by anything 0. So tau should be greater than 0 and tau should be less than t. Okay, so with tau greater than t you will get 0. 0 multiplied by anything 0. So tau value, tau limits should be greater than 0, otherwise this becomes 0. 0 multiplied by anything 0. Tau should be less than t. If it is greater than t, this becomes 0. 0 multiplied by anything 0. Okay, so this in it, from tau equal to 0 to t we have u of t is 1 and u of t minus tau also 1. Both are 1. 1 into 1 into dt, d tau, sorry, tau limits. So what we get, tau 0 to t, so we'll get t. And so this is the function of t, but what are the limits of t? That is important. This is function of t. Okay, so what are the limits? T limits, the t limits are here. From here, t should be greater than or equal to tau, right? T should be greater than or equal to tau. But what is tau? Tau should be greater than or equal to 0, right? From 0 to infinity, tau. So t should be greater than or equal to lowest value 0. So what are the limits of t? Okay, the limits of t from here, t is greater than or equal to tau. But what is tau? Tau starting point, right? Here tau starting point is 0, or from here tau is greater than or equal to 0. So if tau greater than or equal to 0, t also greater than or equal to 0, right? So t is greater than or equal to 0, that is t starts from 0 to infinity. So t has only positive side, okay? You don't have negative side to t. So if you want to represent this is t. This is, in fact, t is a function of t. This is some function of t. That function is t only, okay? And the t limits are only positive side. So this is a function of t, that is f of t, that is t we got, but we need to specify the limits of this t. Limits are from these two equations. T is greater than or equal to 0, t greater than or equal to tau. So t greater than or equal to 0 means only positive side. If you want to represent a signal which is a positive side signal, then you have to multiply it with u of t, right? So if if u of t convolution with u of t, you will get t into u of t, that is r of t. R of t convolution with u of t, where r of t is t into u of t. So tau equal to minus infinity plus infinity, where r of t is t into u of t, first signal. So this is some x of t. X of tau means replace t with tau, u of tau. Second signal, u of t minus tau, d tau. Okay. Whenever you find this kind of u of tau into u of t minus tau, the limits are 0 to t. That's it. Here I already derived. This is u of t into u of t minus tau. This one, u of t into u of t minus tau d tau. Then the limits became tau equal to 0 to t, right? So came from this equation only. U of tau into u of t minus tau. Then tau should be greater than or equal to 0 and tau should be less than or equal to t. From this equation, this is from this equation. So tau equal to 0 to t, and t also greater than or equal to 0. You can clearly see from this. Tau equal to 0 to t means t is upper limit. Upper limit is always greater than lower limit. T is greater than 0. So this is tau, and from 0 to t, u of tau is 1, u of t minus tau is 1. So d tau. Integrate it, t square by 2, 0 to t. That is t square by 2. This is some function f of t. So we need to specify the limits of small t. So limits are 0 greater than or equal to 0. T is greater than or equal to 0. So t greater than or equal to 0 means only positive side. Then how to represent the positive side of the signal? This t square by 2 into u of t. These are important. R of t convolution with u of t, that is t into u of t convolution with u of t is t square by 2 into u of t. And one more signal, from fourth signal, e power minus at into u of t convolution with u of t. You don't need to remember this signal, this result. You don't need to remember, but I'm just solving this. Integral of tau equal to minus infinity plus infinity e power minus 8 tau u of tau into u of t minus tau d tau. That is, here also we got u of tau into u of t minus tau. Then limits become tau equal to 0 to t e power minus 8 tau. So in the limits tau equal to 0 to t, we have this value is 1. So e power minus 8 tau into 1 d tau. E power minus 8 tau by minus a, limits are 0 to t, minus 1 by a e power minus at minus 1. But the t limits are always t greater than or equal to 0. So only positive side, we want to represent the positive side of the signal, 1 by a 1 minus e power minus at with u of t. This is, you don't need to remember, you can solve in the exam if you get a question from this. If you get a question like this, you can derive easily. You don't need to remember the formula. E power minus at into u of t convolution with u of t is 1 by a 1 minus e power minus at into u of t. You don't need to remember this formula. In the next lecture, I will explain the graphical convolution of continuous time signal. Okay. In the next lecture, I will explain the graphical convolution of two signals.